Now this is our 10th project. In this project we are going to see photo manipulation in Python. Photo manipulation means filtering the images in Python. Okay. Here I have created two folders, that is input and output. In input I have two images, that is city and lake, in which we are going to test the images. Okay. And output images for our tested images. Then I have created a Python file named as image1. Okay. In this I am importing numpy and import png. What is this png is? This png is a file created by somebody. Okay. What is this? That means it reads the images as an array and vice versa. Like that it writes the images using array and vice versa. The png file is used to read and write the images. Okay. Now we'll go to our image one. Here I'm creating class, that is image, and initializing x pixel, y pixel and num channels and file name. Then I'm creating path to this input and output images. Just I'm creating folders. Okay, path to the folders. Then now I'm creating x pixel and y pixels. If x pixels and y pixels are num channels, dot self dot x pixel equals to x pixel. Just I'm creating the pixels. Just I'm initializing it. Then if file name dot self dot array equals to read image dot file name. Here I am reading the images in a file and setting this x pixel and y pixel num pixel dot array dot shape. Then else if there is no file or the file does not have num channels. Num channels means that colors, that red, blue and green colors. It's called as num channels. If that is not there means then I'm printing value error. You need to input either file or create a new correct file to the path. Then here I am defining read image. Now this file is going to read our image. See, in image I'm going to read the input path. I'm giving the file name and setting as it to the float. Now I'm resizing this bunch of images and I'm returning the resized images. Now I'm defining write images. Here same like that. In read I'm putting output file and gamma. Gamma is in Max we are using gamma functions and some functions, not like that. It's used to calculate some specific function. Then same like that I'm shaping it, I'm reshaping it and writing that image ping dot writer xyz. I'm writing the image in ping writer dot x comma y. Then I'm opening output path and file name as f and writing it. Then I'm resizing the image. Then at last I'm defining main function and I'm giving the image dot leg. I'm testing the images that it works properly or not. This is for example, if that image correctly comes or not. It has been run. See, correctly it has been. The images has been created. This is tested images, just for if the file are correctly opening or not, so that I'm testing. Now I'm going to the main function, that is transform. Here I'll adjust blur and do some functions. Now only we are going to main. From image1, that is Python file image1, import image. From image1 I am importing this function image. This I created now, this channels that I have assigned the array to 0. This I am taking to transform. Then I am importing numpy. Here the function comes. Here I am defining adjust brightness. Here for brightness I am importing image and factor. Here same like that. X pixel, Y pixel and num channels equals to image dot array shape. Now I am setting this dimension. Then I am creating new image, that is I am creating some duplicate images, that non-duplicate, it's the image mutable image that we can change it, but we can't change it to original image, no. So that I am creating duplicate file which can be changed. Here dot image dot x pixel and y pixel same I am assigning. For bright images, for brightening the images, I am creating the factor, that is 1. If 1 is less than, if the value of the image is less than 1, equal to, it's darken. If the value of image is greater than 1 means I am brightening it. Then I am giving a new image dot array equals to image dot that factor I am giving. Then I am returning that new image. Then after that add context. Add context means adding more color and lessing the colors. Okay. For that I am inputting the parameters image, file, factor and mid. For context image I am setting the mid value, that is 0.5, in which if its value is greater than 0.5 then the contrast is increasing. If the value is greater than or lesser than midpoint means then we are lessing the contrast, that is lessing the color. Same like that before, I am giving x pixel, y pixel num channels and image dot array dot shape. Then same like that I am creating new image dot file. In here I am created that two methods, in which here I am iterating it, and next method is vectorized version. Vectorized version is new version in which we can put it easily. but we are using for function for iterating. You can use both the method, but Wavetite's version is easy. Same like that before. For x in range, x pixel. For y in range, y pixel. Same like num channels. I'm mutating new image and giving x, y and c, that is x, y pixel, x pixel and num channels, creating as xyz, xyc, and image dot array xyc minus mid star factor plus mid. Same like that. I said no. If I'll give some specific mid value, that is constant mid value. If I want to brighten the context, the color means I'll give more than mid value. If I want to lesser mid, a lesser than mid value I'll give. Now I'm returning new image, mutatable image. Same like that, I'm blurring image. Here I'm giving kernel size. Kernel size means if I'm giving 3 means it will take its edges something. It will up. It will take something. If I give 3 means it will take 1.5. Down it will take 1.5 and left and right it will take 1.5 and it blurs the axes. Okay. Same like that. I'm giving x pixel, y pixel, num channel equals to image dot array dot shape. Then I'm mutating like say new image. Then image x pixel, same like that. I'm assigning it. Then creating neighbor range equals to kernel dot divided by 2. This is the variable that tells how many neighbors are actually we actually look at for kernel. For 3 this value should be 1. For neighbor range I am dividing 2 by kernel size. Okay. Same like that. I'm giving for x in x pixel. Then I'm giving total equals to 0. For xi in range 0, I'm giving neighbor range. Neighbor range means I told you no. If I give value that is kernel value 3 means it will take up 1.5 like down 1.5 like left hand side you take that and it will blur the axes. Okay. For that it's taking neighbor range. For neighbor range I'm giving maximum and minimum. Same like that I'm giving for x. I'm giving y and I. Then I'm totaling images. Total plus 1 image dot array. Then I'm giving value x I, y I and c. Then same like that I'm for new dot image new image dot array x comma y comma 0 and total divided by kernel size start 2. Then I'm returning image. Then here I created main function. Then I'm created that name lake equals to image file name. If I give lake means this image should come. If city I give means this city dot image should come. So I assigned that way. Now here comes the I'm writing the images. For bright dot image, take that adjust bright function and lake. See, I said no, for brightening the image I'll give greater than 1, so I'm giving 1.7. Then I'm saving that images as brighten.png. Same like darken, I'm giving lesser value that is less than 1. Like that I'm saving darken images. Then here increased contrast, that I am increasing the contrast. Then I'm giving lake, that is image, and 2, that I'm giving the that is kernel. I'm giving that is factor, that which I want to make the color brighten, and now 0.5 I'm giving the midpoint. Now same like that I'm saving the images as increase contrast .png. Then discrete contrast. Then I'm giving adjust contrast. Then I'm giving image. Then I'm lessing the contrast to 0.5 and I'm giving the midpoint 0.5. Then I'm saving the image as decrease contrast. Then I'm blurring the image. I'm blurring the image. I'm taking blur function and giving image, and I said no, I'll give 3. 3 means it will take down 1.5, up 1.5, blur the axes, edges or axes. Same like that, I'm blurring the kernel 15. Then I'm saving blur dot 15. Now I'm run the see the output has come. See, I'll show. See, the images has been brightened. I'll see the original image. This is the original image. This is the brightened image, and this is the darkened image. Same like that, decreased contrast, that is contrast, the color has been decreased. Then see the increased contrast, the color has been more, it has been created. See up here and this, it's colorful. Then blur image, see the edges, see it took no, the edges all have been blurred. Then for 15 nothing, it has been showing fully, it has been blurred. Now this is our project. Next project I'll explain you many saturation like Sobel X, like that I'll explain in next project. Okay, thank you.